everyone, we're going to determine whether the series is convergent or divergent. Let's go ahead and use the limit comparison test for the series. So if we do that, we're going to let a sub n equal our original series, 1 plus 4 to the power of n divided by 1 plus 3 to the power of n, and compare it to the series b sub n is 4 to the power of n divided by 3 to the power of n. So by our limit comparison test, this would be the limit as n approaches infinity of a sub n divided by b sub n. And if c is a finite number and greater than 0, then either both series converge or both series diverge. So this is going to equal the limit as n approaches infinity of 1 plus 4 to the power of n divided by 1 plus 3 to the power of n divided by 4 to the power of n divided by 3 to the power of n. Okay, so let's just multiply these by flipping that around. We're going to get the limit as n approaches infinity of 1 plus 4 to the power of n divided by 1 plus 3 to the power of n. You flip this around, we're going to get 3 to the power of n divided by 4 to the power of n. Now, the next thing I'm going to do is rearrange this and write this as the limit as n approaches infinity. I'm going to put this 4 to the power of n under here. So I'm going to write this as 4 plus 4 to the power of n divided by 4 to the power of n times 3 to the nth power divided by 1 plus 3 to the power of n. Now, this one we can simplify here as the limit as n approaches infinity. And this put this denominator under each piece. So this will be 1 divided by 4 to the power of n plus 1. And then it's going to be times this. Now, I'm going to try to squeeze this in here, but I'm going to multiply this piece right here by times 3 to the negative n power. So we can take the limit. That's the only reason. So that's going to leave you 1 in the numerator, and the denominator we're going to have 1 divided by 3 to the n power plus 1. So when you take the limit and you substitute in infinity, this is going to go to 0. So you can have 0 plus 1 is 1 times, this is going to go to 0, and then you're going to have 1 divided by 1 times 1. This equals 1. So this is your C, which is greater than 0. So all we know now is that they either both converge or both diverge. So now let's look and see what we can look at. This one's a lot easier to see. It's a geometric series, and for the sum of b sub n equals the sum of 4 thirds to the power of n. Since it's geometric and absolute value of 4 thirds is not less than 1, it means it's divergent. Since it's divergent, according to my limit comparison theorem, that means the sum of a sub n, which equals this, I'm not going to write it, is also divergent. You could also use the comparison test and notice that 1 plus 4 to the power of n divided by 1 plus 3 to the power of n is greater than 1 plus 4 to the power of n divided by 3 to the n plus 3 to the n power, which is greater than 4 to the nth power divided by 2 times 3 to the nth power. And that equals 1/2 4 thirds to the nth power. This one looks a little more complicated. This one, I think the geometric series one is a lot easier. But thank you. Have a nice day. Bye-bye.